Okay, today we're doing miscellaneous exercises. Example 1 says the volume of a sphere of radius r is determined by the function with the rule VR equals 4/3 pi r cubed. We should know that. That's the volume of a sphere anyway. It says state the practical domain of the function v and find v of 10. Well, the practical domain means the domain that we could possibly have. Now, that means for r because r is the one that we're dealing with. Well, the smallest r value that we can have is 0. So we can't have anything smaller than 0 because how can we have a radius that's less than 0? So the practical domain is 0, and we won't include 0 because how can we have a volume when there's no radius? And the biggest radius that we can have is infinity. And again, we won't include that one because it continues. Now, v of 10, if we substitute v of 10 in there, so when r equals 10, we get 4/3 times pi times 10 cubed. And we'll work that out. We've got 4,000 on 3 pi. I won't work it out, I'll just leave it like that. Therefore, the volume is 4,000 pi over 3. And because there's no units, we'll write cubic units. Example 2. If f's such that reals to reals of f of x equals ax plus b, f of 1 equals 7 and f of 5 equals 19, find a and b and sketch the graph of y equals f of x. So we're substituting these two in and we should get two equations. So f of 1, when we put 1 in there, we get a times 1, so it's a plus b, and this one equals 7. That's what they tell us there. When we put f of 5, so x equals to 5, we get 5a plus our b, and that equals 19. So this is equation 1, this is equation 2. You can solve it using matrices, you can solve it by substitution or elimination, it's up to you. I'm going to solve by elimination, so I'm going to go number 2, equation number 2, and I'm going to take away number 1. That gets rid of my b's. So 5a minus the a gives me 4a, b minus the b gives me 0, 19 minus 7 gives me 12, therefore a gives me 3. And if a is 3, I'm going to substitute a equals 3 into equation number 1 and get 3 plus b equals 7, therefore b equals 4. Therefore my rule is f of x equals a, which is 3x, plus b, which is 4. Now we're asked to sketch that, so make sure that you read the question fully. So here we go, x there, y there. I'll just put some units in here. 1, 2, 3, -1, -2, 1, 2, 3, 4, -1, -2. I'm going to sketch it the easy way by marking in the y-intercept first, which is 4. So there we go. I didn't leave myself enough room, but usually I'd go up the 3, 1, 2, 3, and across 1, so it would be there. And go like that, and it will go through -4/3. That part there is a -4/3. So -1 1/3. So there's my graph. Example 3 says find the quadratic function f such that f of 4 equals f of -2, which equals 0. So if these two are like that, that means that they're factors. So the rule becomes f of x equals k. I don't know how wide or narrow it is. And then it'll be x minus the 4, because that's a factor, because it equals 0. And it would be x minus the -2 becomes plus 2. The other part that we know is when it's 0, we get 16. So if we substitute f of 0 in here, we get k. This is -4. This is 2. And the whole answer is 16. This is -8. K equals 16. So k equals -2. So therefore my rule is f of x equals negative 2, x minus 4, x plus 2. Now I can expand that and collect like terms if I if I really want to, excuse me. So we've got negative 2, x squared plus 2x minus 4x is minus 2x. This becomes minus 8. So I'll get minus 2x squared plus 4x plus 16. Probably the factorised form would have been easier. 6F questions.